Dear students, I am Suresh Halbandge from Satish Pradhan Sadhana College, Thane. Today, I am here to explain the phenomenon of total internal reflection with the help of physics simulation. Now, we all are aware of the phenomenon of reflection of light, right? Now here we can see there are two media. Mainly this is the upper medium and this is the lower medium. Here the upper medium is air and the lower medium is glass. So here upper medium is a rarer medium and the lower medium is a denser medium. Now we shall see what happens when the light is passing from rarer to denser medium. Okay, now this is the animation. I'll click on this. Now if you look at this at different positions, I'll change the angle. Right, when I change the angle, we will find that for different angles. So this is, okay, we observe this is the angle of incidence, this is the angle of refraction, and this is the angle of reflection. Okay, we are familiar with these aspects. Now, okay, here instead of taking the ray of light, I will try to take the beam of light. Okay. Wave, I take the beam so it will be clearly evident. Now just I change the angle. When I change the angle, we can observe the angle of incidence. Okay. This is the angle of incidence, this is the angle of reflection, and this is the angle of refraction. You can clearly observe this. Now what I do is, I will change the medium. Upper medium I shall take it as a denser, which is a glass. Lower medium as a air, right? Now I will change the angle, right? Now angle of incidence is 0 here. The ray of light is incident normally. Now when the ray of light incident normally, angle of incidence and angle of refraction are both 0. Here the Snell's law of refraction fails. Sine 0 upon sine 0, it is infinity, and Snell's law becomes invalid. Now I'll slowly increase the angle of incidence. As the angle of incidence increases, the angle of refraction also increases. At a certain angle of incidence, the ray grazes on the surface. Now just if I tilt it, this ray will graze along this surface. Okay, at a certain angle, the refracted ray will graze along the surface, and that angle of incidence is called as the critical angle. Now, if the angle of incidence, okay, if the angle of incidence is greater than the critical angle, now see this way, slowly I increase the angle. Now when the angle is greater than the critical angle, now this angle is greater than the critical angle. Now there are two conditions. The ray is passing from denser medium to the rarer medium, and at a certain angle of incidence, that is I, which is greater than IC. Okay, angle of incidence is greater than the critical angle, then we find that the ray is totally reflected in the same medium, and this phenomenon is called as total internal reflection. So dear students, for total internal reflection to take place, there are two conditions. Light should pass from denser medium to the rarer medium, and number two, the angle of incidence in the denser medium must be greater than the critical angle. Then and then only total internal reflection takes place, otherwise no. Okay, so just I will start from the beginning. I'll slowly increase the angle of incidence and see what happens to the angle of refraction. Okay, what happens to the refracted ray? At a certain angle, we find that the refracted ray vanishes, meaning that refraction does not take place and the ray is totally reflected in the same media, and this phenomenon is total internal reflection. I hope you all might have liked this. Thanks a lot.